Hello, geometry. Welcome back to your most favoritist time of day. The time that you're going to do math, specifically geometry. And if you watched my last video, or did the last homework, you're probably thinking, what is this? Right? It's trigonometry. And we learned in the last video, we learned about these fancy things called the sine, the cosine, and the tangent. Right? So, let's just jump right into it. Right? Why not? A little review. We had sine, cosine, tangent. Now, each one of these has a story. We don't really go into that story. I'm posting a video, finding one that I like, posting a video about what goes, like how these came about. You can watch it. It's pretty cool. We're just focused on the application, right? Now, the application of these is that the sine is like an operation. When you take the sine of an angle, and you'll see it as the sine of like an angle theta. In this case, they mainly use like A. And if we have a triangle, and this is A, let me do a better triangle than that. That's an ugly triangle. My cat's going crazy right now. Dude, Fang, you just want to play. Sorry, Fang. So if I have a triangle, let's just do one big one for all these examples. And this is angle A. And say this is 3, 4, and 5, right? 3 squared plus 4 squared would equal 5 squared. It works. So then triangle A, if we take the sine of that angle, we talked about how the operation of the sine is just that this is a ratio. You take the sine of that angle and it equals the ratio of a certain sides in a triangle. In this case, it is always the opposite for sine over the adjacent side. And we talked about how the opposite is just the side opposite your angle you're taking of. So, you hear my cat in the background? Dude, he's really on something right now. Well, come on up, Fang. Oh, now he's quiet. Okay, so like I was saying, we take, whenever we take the sine of A, it equals a ratio of sides, that sides being the opposite over hypotenuse. And that's the one I didn't label because my cat distracted me. That's the longest side, right? So that hypotenuse is, dude, oh my goodness, I can't. Okay. That hypotenuse is the longest side. The opposite is the side opposite the angle you're taking the sine of, and then obviously the adjacent angle is the side adjacent that's not the hypotenuse. So you're gonna have two sides that are adjacent. One's gonna be the hypotenuse. One is what they call the adjacent side. And so the sine is equal to the hypotenuse over the adjacent. The cosine, which we just call cos of A. That would be adjacent over hypotenuse. And then the tangent is equal to opposite over adjacent. Opposite over adjacent. And yeah, dude. Oh my goodness. Sorry, my cat's going. He's like, Fang, you're funny. His name's Fang, by the way. We call him Fang because he has two fangs. He's an overbite, so his fangs stick out. You're funny. He's just desperate for affection right now. Or to play, I don't know. All right. And so if we applied these, then the sine of A would be the opposite over hypotenuse, so that'd be 4 over 5. Adjacent over hypotenuse would be 3 over 5. And the tangent would be opposite over adjacent, so 4 over 3. And if you, and you could figure out that angle, And that's actually what we're going to be doing today. So in homework number 3, we mainly solved for missing sides, right? And I'll just kind of brief that really quick. Oh my goodness, Fang. No. He's attracted to my mouse. Fang, no. Okay, I'm not kidding you guys. This is actually happening. In homework number 3, like, we solved for that missing side. Now in homework number 4, they show this thing and they're like, you have to solve for missing angles and sides. So they start out with what we did before, missing sides, and then eventually they get to, like, starting number 7, they do missing angles. So I kind of like this because it reviews what we just talked about, and then it goes into 7, 8, 9. So to finish our review, let's just do some of these ones. So I'll do number 1 to reinforce what we were just talking about. Somebody pick a color. Anybody? Green, purple, blue, blue. Blue sounds good. Okay. So I take the sine, or sorry, I always just choose sine. We got to figure out which operation we're going to use, sine, cosine, or tangent. So what something I like to do is label all the sides first. Obviously, this is the hypotenuse. I'm just call it H. This is the opposite, and then this is the adjacent. So we need to do the hypotenuse and the adjacent. So if you go over to SOHCAHTOA, which one uses the H and the A? Well, cosine does. So I'm going to take the cosine of 63. And that's going to equal the adjacent over hypotenuse, so x over 16. And then you would multiply by the x, or by the 16, and then you would get the cosine of 63 times 16 equals x. Now this is where you're going to get your handy dandy scientific calculator. And scientific calculator, I found one that's really nice. It's called the Desmos calculator, Desmos scientific calculator. And so if you go to main, it has all the sine, cosine, tangent operations. So you do cosine 63, make sure you're in degree, times, what did we say, 16? 16. No, it doesn't. Times 16. 7.26. So our answer for x, 7.26. And you're done. That's it. Okay. So that's how you do those. Now let's explore the problems after 7 through 8. Now let's just start with number 7. So let's approach it the same way. Let's label our sides. So this is hypotenuse, this is the opposite, and this is the adjacent. And then that's our angle, obviously. Okay. So we need to use the opposite and the hypotenuse. So again, SOHCAHTOA. If you don't know what I'm talking about with SOHCAHTOA, it's just a little anagram or whatever. Sine is opposite over adjacent over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And I talk about that in the video for homework number 3. Homework number 3. So, so we need the opposite and hypotenuse. So we're going to go sine. Opposite and hypotenuse. So the sine of our angle x is going to equal 4 over 6. 4 over 6. Now here's the thing though, is normally we just plug this into the calculator and got a decimal out and then solve for x. Now we can't do that necessarily. It doesn't work like that. So here's what I'm going to say. Instead of just plugging in a calculator, we have to do something else. Now I'm going to take a little hiatus. I'm going to show you how to solve this. If I had something where I was doing like multiplication and I needed to cancel it, I would do division, right? And if I had addition, I would cancel it with subtraction. So if you think of this as an operation, there has to be an opposite. So the opposite to this in your calculator, if you go to function, are these little ones right here. Sine of -1, cosine of -1, tangent of -1, right? And it works because if I take this and I do the inverse cosine of that, I get 63 back out. Like they cancel out and I'm just left with 63. So what we actually do is we take both sides, and how we write it is we say, I'm going to take what's called the inverse sine, or the inverse sine of both sides, and then if like they cancel each other out. So what you're end up going to actually do is apply the inverse sine to both sides, and those cancel out and you get x, and then in your calculator you're going to plug in the inverse sine of 4/6. So you go to Desmos, type in the inverse sine of 4 divided by, where's mine? Divided by 6, and then in parentheses, no, come on, dude. Okay, and you get 41.81. So x then equals 41.81. Now here's the thing, this makes sense. This is a good amount of degrees right here, right? It seems pretty good. Now if you get a number, like here's what I would say, if you're in radians and you get this, does it make sense to have an angle that's 0.72 something? No, that would be a really small angle. Don't freak out, you probably need to change it to degrees, okay? And there you go. That's your answer. So let's do a couple more problems. Let's do, this one we used what? Sine. This one we would use tangent. So let's do number 8 and use tangent. Okay. So set up your thing, right? We have our opposite side here. Let's do the different color. Opposite. This one's adjacent because this one's the hypotenuse, right? We want to focus on the opposite and adjacent. So if you remember, we have the TOA, SOHCAHTOA, which uses the opposite and adjacent sides. So I'm going to take the tangent of x, because that's their tangent that uses the opposite and adjacent, and that's going to equal my two sides that I have, opposite over adjacent. 29 over, oops, sorry, I need to write. Tangent of x, and that's going to equal 29 over 14. Okay, so 29 over 14, now I take and I apply the inverse tangent to each side. And they cancel out, and on one side I'm going to be left with x. And then I just, sooner or later, you're going to just figure out, oh, I just need to apply the inverse tangent of that ratio. So then I'm going to apply the inverse tangent, and you won't even write many of these steps out. And then I'm going to say, hey, you need to show your work anyway, right? It happens every year. That's okay. The inverse tangent of 29 over 14. So I'm going to go over to function. I'm going to clear this. I'm going to say the inverse tangent of 29 divided by 14. And that equals 64.23. So 64.23. And again, does that make sense for that angle? Does it look like about 60 degrees? Yeah, it looks like about 60. This would be about 30 something, 90. There you go. Probably right. In fact, I know the answer to this one. I am right. All right. And they're all kind of the same. You know, once you get the trick down, you get the trick down. These ones, yeah, they like to throw these ones in at you, some word problems. I'm gonna let you guys do these ones on your own. The word problems, just set them up. These ones, yeah, they're kind of tricky. Just like for number 13, just focus on this triangle first, right here. That's my hint to you. Focus on this one first, and use the trigonometric ratios to solve for QS. Once you have QS, you can use it again to find PS. Right? So the first thing you're going to do is you're going to set up the tangent of 28 is equal to PS, call it X, over 39. Solve for X, use X again to solve for PS, this one right here. That's how you do that one. Number 14, start with this triangle, and then you're going to set up an equation, and you're going to want to solve for BD. So call BD X, and you're going to again set up a tangent function because it's opposite over adjacent. So you're going to say the tangent of 47 equals X over 18. Again, same thing, solve for X, and then use X and 7 to solve for the angle CDB. So you're going to need to use an inverse cosine, I think, to solve for that. So I think, again, somewhere down the line, you're going to have to use inverse cosine, the adjacent over that hypotenuse, yeah. But solve for X first, and then use the inverse cosine. And then these ones, set up a picture, solve the picture. Once you get a picture, word problem goes away. There you go. Yeah. So that's how you do it. Some cool things to note about all this stuff is that this trigonometry has many other applications. This is just the beginning. This is the very scratching surface of like how we teach students right off the bat, but it's all over the place. So I hope you stay tuned. It doesn't go away, trust me, especially if you guys are going in, and I know some of you guys are going into it, to Algebra 2 and pre-calculus, and especially calculus. Okay? It's going to be a fun time for you. Really, I mean it. Okay, kind of a quicker video, but watch both of them and then watch the video that I'm going to post just after this. And again, send me messages if you need help. All right. Have a good day, everybody. See you later.